Okay, sorry for the slow start. So 3D printer basic instructions. So 3D printers are going to be something I think most of us will start using in the future. Some of us sooner than others. The uses of them are so varied, and what you can do, especially as a DIYer, make your own brackets, make your own clips and all sorts of things. It really opens up a whole new world of creativity for everyone. So what I'm going to do is just try to introduce basically what it's all about and some of the things that you sort of need to know. So basically, what is 3D printing? So 3D printing is also known as desktop fabrication, additive manufacturing. It's a prototyping process where a real object is created from a 3D design. The digital 3D model is commonly saved in what they call STL format and then sent to a 3D printer. The 3D printer then prints the design layer by layer to form a real three-dimensional object. So the basic process of 3D printing is you start off with a CAD program and you draw your program or draw your object that you want to make to the dimensions you want to make. Then from there you then go to a program which is called a slicer program. So the slicer program is a program that basically sets up your parameters for your printer to actually print. So what it does is slices your object into layers so it can then be printed out by your printer. And then from that you've got your 3D printing. We also have 3D scanners, so you can scan objects and you can import those into a CAD program and then modify those, or you can go straight into your slicer program and just basically copy it straight away. So a lot of options and choices for people to do what they want with when it comes to creating things. So you might have a broken part or something like that. You can easily copy that and fix that up. So that's the end result. So there are actually quite a lot of types of 3D printing, and we'll just quickly touch on those. So material extrusion, which is the one we will discuss and the one that's commonly used. We'll discuss that further shortly. But there's vat photo polymerization, which is a 3D printer based on the vat method, which is a container filled with a polymer resin, which is then hardened with a UV light source. So it's a different way. It's using resins instead of an extrusion plastic. Not as commonly used. It's more of a commercial industrial use. Then there's material jetting. In this process, material is applied in droplets through a small diameter nozzle, similar to the way a common inkjet printer works, but it's applied layer by layer to build a platform making a 3D object and then hardened by UV light. So basically that's a mix between the material extrusion and the vat polymerization. Then we have binder jetting. With binder jetting, two materials are used, powder-based material and a liquid binder. In the chamber, powder is spread in the equal layers and the binder is applied through jet nozzles that glue the powder particles to shape a 3D programmed object. So that's another method that's used. Then there's powder bed fusion. This powder bed fusion is becoming popular with steel fabrication and things like that for 3D. It uses a high power laser to fuse small particles of plastic, metal, ceramic or glass powders into a mass that has the desired three-dimensional shape. The laser selectively fuses the powder material by scanning the cross-sectional or layers generated by the 3D modelling program on the surface of a powder bed. After each cross-section is scanned, the powder bed is lowered by one layer thickness, then a new layer of material is applied on top of the process. The benefit with this is objects don't need support because the powder itself gives support. I think this method is going to become more popular in the future because it has much more uses for different materials, especially for steel fabrication and things like that. So this will be, I think, powder bed fusion will be something we'll see more in the future. And then there's sheet lamination. So sheet lamination involves materials in sheets which are bound together with external force. Sheets can be metal, paper or form of polymer. Metal sheets are welded together by ultrasonic welding layers and then CNC milled. Again, more of a commercial application. And then direct energy deposition. This process is mostly used as a high-tech metal industry in rapid manufacturing process. The 3D printing apparatus is usually attached to a multi-axis robotic arm. It consists of a nozzle that deposits metal powder or wire to a surface and an energy source laser. So there's many different ways that 3D printing is being developed nowadays. So it's a massive field that's really growing at a phenomenal rate. People are sort of saying that, and I believe this myself, that This is going to change a lot of how manufacturing is done in the future, because especially for small items and niche products and things like that, they won't have to be made overseas anymore. People can make them themselves. There's actually 3D printers coming out now that will actually print a PCB board for you. So you can prototype your own electronic board. So basically, the way things are heading is someone can be at home in their own little office, and they can basically build and prototype a complete system. The board, the case, and everything that goes into it. Because these are the things we'll be able to have very shortly, easily accessible. So I'll go down the material extrusion method, which is the one that which is commonly used now. So it's fused deposit modelling technology. So it works using a plastic filament or metal wire, which is unwound from a coil and supplying material in an extrusion nozzle, which can turn the flow on and off. The nozzle is heated to melt the material and can be moved in both horizontal and vertical directions by a numerically controlled mechanism, directly controlled by computer aiding manufacturing CAM software. The object is produced by extruding melted material to form layers as the material hardens immediately after extrusion from the nozzle. So just basically layer by layer, and that's why we talk about a slicer program. The slicer program slices into layer to layer to be printed. So basically, as the diagram shows here, just this applies layer by layer. So there's several materials we can use with a normal 3D printer that we currently have available. So the general two main ones are ABS and PLA. They're the main two, and you'll find that most printers these days will ship with a spool of ABS and a spool of PLA. Mine was shipped with one of each. Both have their properties, and so ABS is, if you can understand how to say that word, it's the most commonly material used in 3D printing. It's similar to what's used in Lego. It's very durable, slightly flexible, lightweight, and can be easily extruded, which makes it perfect for 3D printing. It's what I generally use. I've found it quite good to use. And then we've got PLA, which is another commonly used material. It's actually biodegradable, so that's why I haven't used it, because its UV rating properties aren't very good. So I've used it generally to make clips for the lighting to be held on catenary wire and things like that. So PLA was the obvious choice, black PLA, because black and black ABS was the choice because black helps add UV properties, because black is a carbon-based colour, so inherently it adds UV properties. So because ABS in its complete natural form isn't actually a product that's UV rated, but with some polymers and things like that put into it, they actually make them UV rated. So the spools I'm using are UV rated. So basically it goes down to ABS versus PLA for most people, because this is the choice that most people are going to use, either one or the other. So basically they extrude at different temperatures. You'll find ABS requires a heated bed to work better. PLA doesn't really benefits from using a heated bed, but you don't necessarily need to. So ABS works reasonably well without cooling. So ABS is one of those ones where you really need to have an enclosed 3D printer. For the fact is, with ABS, if you have drafts and cool drafts come things, it makes things curl and doesn't allow the print to work very well. Where PLA, I would actually take the lid, the top cover off my printer and the side little vents off and open the door up so it actually vents very well, because PLA sort of prefers that kind of condition. So it sort of just gives you a couple of ideas of what the comparison between the two are. In the end, they're both basically the same price. So it goes down to what application you want to use. I haven't done much PLA printing myself. The little bit of printing I did do, it worked okay, but it still needed a bit of tweaking. So, but there's other materials we can use too. So we have nylon. So nylon is a versatile 3D printing material which prints in natural whites with a translucent surface and conservable colour. It's another material. It requires about 230 to 240 degrees. It also has different properties that you can use for different. One of the more common ones used, but it's becoming more popular. TPE, it's a flexible 3D printing material that feels and acts much like flexible rubber. It can be used to make parts that can bend and must flex to fit their environment. So it's more of a rubbery kind of material. Then we've got polycarbonate. It's a much stronger, durable, harder material. We've got a product called laywood, which is an extrusion plastic material that's actually impregnated with wood. So it smells like wood, it sort of looks like wood, even cuts like wood, but it doesn't feel like wood. And then we've even got new conductive filaments coming onto the market. So you can start making electrical things with electrical traces on them. So there's a lot of things, because the market is still very early and it's developing very quickly. There's many other exotic materials constantly being developed. So in the next couple of years, so we're going to see so many changes to this field, and what we can do with it. It's just going to open up a whole new world of things. We talk about DIY. Well, this is going to really bring DIY really to everyone quite easily, and cost effectively as well eventually. Then we have a thing called support materials. So generally we can build an item, so it might have an overhang, or it might be a box, so the top of it's got no support. So what we want to do is support that material, because it can't support itself because gravity, basically. So to try and get away with that, you use a thing with, like, what I've got is a dual head extruder. So I can use my normal plastic, and then I can use a material, a PVA, which is a polyvinyl alcohol, which is easy to print with, and it's great for supporting objects, because I can use it, and then when I finish with my object, I can just throw it in a bucket of water, and that support material will just dissolve away, allowing me then to have the item that I want without that support material. Because what happens is, a lot of times people, if with a single head extruder, if you're going to use support material, what you have to then do is you have to then break off the support material and then clean the face up that had that support material. So using this on a dual head extruding system is much better. As you can sort of see in the picture below, the support material there is in that box in water, and that's how it dissolves, and you end up with a clear, empty kind of shape in it. So it allows you a lot of ways to be able to do what you need to do. So important tips when printing. So if printing ABS, which is similar to Lego, then buy an enclosed 3D printer, as temperature stability is important, which I already mentioned. Leveling is very important. Leveling is very important. I can't sort of mention that enough. There are new printers coming on the market that have self-levelers, but of course you have to pay extra premium for that. All right, so what you'll find is, if you have the extruding tip too close to the base, you'll find your plastic will stick to the base and become very hard to remove. If you have it too high and too away, what you'll find is it won't stick to the base, and then it'll start moving during the process, and you end up with a spaghetti of plastic all over the place. Leveling is very important. Take your time getting your leveling done right first. Generally, once you've done your leveling, you don't have to worry about it pretty much after that. Place the print on a solid platform that does not shake and move when the printer is working, because if you're on a very flimsy and that head's moving around, the whole thing's moving around, you can tend to sort of cause yourself some problems when it comes to print. Because we're talking, 0.01, 0.02 of a millimetre. Now, we're talking very small amounts here that these things print at. So again, I said consider dual extruder. It allows two different materials or colours, and is great for using dissolvable support filament. Choose a model that will run standalone via SD card or internal memory and not require a computer to run. So a lot of the DIY kits and earlier versions required to be hooked up to the computer permanently. So if your computer shut down or anything like that, then your print was lost. A lot of the new versions now are coming with internal memory or SD cards, what I've got. So basically it becomes a standalone kind of thing. Choose a good slicer program. So the program that slices our printing layer instructions. because this can save you a lot of time, because the way it decides it's going to print, you want it to be able to print in the most efficient way and save yourself time. And you want to be able to play with some parameters as well. So, you know, the slicer program will allow you to say, okay, I'm only going to fill in my object at 20%. And I'm going to have my wall thickness 2 layers, 3 or 4 layers. So you can actually, the structure you're building, you can say, I want the wall layer to be 3 layers thick, and it's going to be 20% infill. All right? Or you can say, I want to save material. It's only a very prototype. I just want to see what it looks like. So I'm only going to go make it 1 wall thickness, and I'm only going to go 10% infill. And that way you have a very light object, but there's no real structural integrity, but gives you the idea, but saves on material and saves on speed when printing. So slicer program is a very important part, I think. I use a program called Simplify 3D. So when printing ABS, then you might consider having the printer in a location that is well ventilated, because ABS does let off a bit of an odour when it's been extruded. PLA doesn't let off as much odour, but you'll definitely notice it. And so I have mine sitting in my garage because I don't want the house smelling of plastic. So when printing a new material, always do a small test piece to ensure your settings are correct. I actually have found that objects are easy to remove from the build bed if left to cool down, and then you reheat the build bed. And as it's reheating, then you can remove it, because what you've got to do is a difference in temperature between the two materials. So I find that actually helps you remove material much easier, because one of the things is it's about getting the material to sit on very well so it doesn't move, but it's a balancing act between making it sit and not making it stuck. So making it stuck can be really annoying because you pry and they can stick damn well sometimes. So start with the defaults. So when you're playing around, start with defaults for printing, and then experimenting, make some small cubes, and then adjust various parameters to see what they do. Get to learn the printer, get to learn what it does, because all these parameters make a big difference to how things come out, how the end object comes. You know, if you want something that's very functional, you want something a bit more solid, a bit more structural integrity, you want to know what parameters go in to help make that happen. So it's always good to do and play with that first. So build platform adhesion. So this is one of the most important things, because if you haven't got that right, you end up with a mess. It becomes very frustrating. So I use a thing called build tack. So build tack is a sheet that I stick to my build plate, and it is a really good, I found it really good. It makes it really simple. It sticks very well and lasts quite a bit of time. You know, I was able to produce, I reckon, 300 clips with one sheet, and that was over a period of three and a half weeks of constant use. So it lasted quite a bit of time. But I reckon I could have got longer life out of it if I just didn't keep printing exactly the same spot every time. So if I'd moved everything slightly over, then I would have got more life out of that build tack, because it was then printing on a fresh piece of build tack as opposed to always on the same spot. Now, Phil uses capped-on tape. I've not actually used capped-on tape. It's a tape that you apply to the base there. It's what Phil's used. I mean, I've not really used, because I've had such good success with build tack, I just haven't bothered going with anything else. So to me, build tack, it actually came with the printer when I first bought it, and so that's what I've just been stuck using. But capped-on tape's another thing that's very commonly used. And then people can modify to put a glass bed. So glass is supposed to be very good when it's heated. But again, you may have to apply what they call a slurry to the glass bed to help things stick. So I find the capped-on tape and build tack, I think they're the best things to start with when you're talking about adhesion and getting good adhesion. So features when looking for a printer. Close is better when printing ABS. Dual head allows easily print dissolvable print materials, or print with 2 colours. Standalone printer that doesn't need connecting to a computer. A heated build bed. Self-leveling bed, these models are more expensive. Self-calibrating. A lot of them nowadays are coming out self-calibrating. The earlier versions don't, which means you have to calibrate every time, which can be a bit of a pain. Print speeds, again, they vary. It's like any printer that you can get different print speeds. Print resolution, Generally, you want to look at something that can go, I generally print with 0.2 millimetre resolution, but the one I get can go down to 0.08. So it can go down quite a fine resolution. But of course, as we know with printers, the finer resolution you go, the longer it takes to print. So it's about balance. You print bed size and height, so that basically determines of what you can actually build. Does it use proprietary filament, or can it be easily modified? So a lot of printers will actually stick you with using their filament, and that's where you get stung in the end. So example is the Da Vinci range. They use a cartridge, and it's quite expensive. Cheap to buy the printer. It's one of the cheapest on the market, but the consumables are quite expensive. Where the one I bought, it only, it's designed to use proprietary spools of 700 grams. But the very first project I did with it was build a spool holder that could hold generic spools. So I just went online and to a place that had lots of files, did a search, bingo, someone's already done it. Downloaded the file, built it straight away. So that was the first project I built. Something to modify the printer. Important thing, look at what the slicer software is. Does it have good support? So Simplify 3D is a very good program to use. And then you've got to look at community and manufacturer support. So there's sort of points you look at when you're looking at a 3D printer. So then we look at types of free CAD software, because I think most of us are going to only be interested in free software, not purchase software. So Google SketchUp is one piece of software that's out there that people can use. It's not too bad. We've got Autodesk 123D. This is what I actually use. It's and I'll do a quick demo of that shortly. Then we've got Tinkercad. That's an online-based CAD program. These are all free to use. Blender, 3D Slash, FreeCAD, Seamless 3D. So there's plenty of free ones out there to get your hands on to play with, and a lot of them are actually made to be easy. So Tinkercad is one of those ones that's actually aimed at school kids. So there's a big push towards training kids up now to be good with 3D CAD programs, because that's where a lot of the future is going to be. There's going to be a whole new industry made up of people who are just great with 3D CAD programs that can design and build things. So then we've got places where we can just, if we don't want to build something, we can just go to places that we can just download files and just do what we want. So Thingiverse is a really good place. It has a lot of files there. You can search and just download and print. You Imagine, Turbo Squid, Pinshape, The Forge, My Mini Factory. So plenty of places, and that's just a small fraction of places. And all these repositories are getting more and more files in them, so you're finding it easier and easier to find what you need without having to build. So, here's an example here. That's the 3D file there on the left side. That's a produced. So this is an engine block that someone built, designed, and that's how it came out in the end. So you can see, that it's very intricate in what they can actually do. So what I'll do is I'll just quickly fire up. So I use this program here, which is on the other screen, which I'll drag across when it starts. So you can import designs, so you can import things in. So if I want to sort of, you've got shapes here. So I want to build a box, and then you can, I can then pull that up, grab that arrow, and I can move it out, things like that. You've got your sizes here. So you've got a bunch of tools up here. It's just basically just using a drawing program pretty much to allow you to then be able to develop shapes and things like that. Once I've got that, then I import into my slicer program. So what I'll do is I'll use Simplify 3D over here. Showed it there. Where's it gone? Start again. So something's going on with my computer. It's doing too many weird things today. For some reason it doesn't want to start. But this is the software that actually flash print, which is actually software that comes with this printer. So it's another piece of software. So it allows us then to import our build. So I can grab a 3D file. So that's just gonna, so that's basically it. Then I can then load that into a file. Fortunately, I prefer to show Simplify 3D because that's what I normally use. But I don't know what's going on here. I've got the icon down here as say the program's running, but it's not anywhere to be seen. So I don't know what's happening here. Okay. Yes, I can't even see it on here. We'll see. No, it's actually. I have to find out what's going on there because it's worked every other time and now for some reason it doesn't want to work. Very frustrating. But in a nutshell, that's basically what we sort of do. That's how we sort of do it. We sort of, you create your CAD program, then you put in the slicer program, and then you either orientate it the way you want, or make multiples. So you say I want to produce 10 of these because they're exactly the same. So you can just copy and paste and things like that. So that's pretty much a quick demo of that. So I've got the printer over there. So I'll just quickly move over here. My finger's a bit greasy from before, I think. So this is so that's the build tack I was talking about that I'm using here. This takes two spools, so dual head. What I've actually done here is I've preheated this already, so you can actually preheat your bed. So it's now temperature ready to start printing. So I built this. So basically, this was what was produced. One of these. I just built one of those. One of my first projects. So I could then take, because normally it takes these smaller spools, but now I've been able to make it take these larger spools. So basically just to print, it takes an SD card here. So all I want to do is I want to print a file. I've got them already on the SD card here. I've got a bunch of files here. So what I'm going to do is just make something very quick. I'll make a Space Invader. So this just makes something fairly small. Shouldn't take a great deal of time to build. It should start. Challenge accepted. So what I'll do is it sits there red now, and what it's doing is it's just waiting until they get these temperatures to the right temperature, which is pretty close now, so it's going to start printing now. So it's just basically the same as a printer, but it's three-dimensional now. So it'll just go ahead and just keep doing that until it's ready to go. But it's a quite unique feeling to have, and it's something I'm still getting used to. That I can actually build something and fix something at home where previously a little plastic bit would make something that was expensive worthless because you couldn't get that replacement part. Now you don't have to worry about it because you can fix it and make it yourself. So that's basically how a 3D printer works. It's pretty straightforward. It's very useful. One of the best things I've bought for a while, I think.
So, important question, Ed.
Yep.
How much?
Okay, for this model here, this model was $1,450.
You're getting them cheaper.
They're getting cheaper. So this is a 14. So this is $1,450, but this is a dual head one model, and it also has memory and things like that. You can get them for $600-700 now. They're coming down in price very quickly. When you look at all these companies at the moment, they're vying for their position at the moment in this market. A lot of companies realise that there's a lot of money to be made in the future, so everyone's coming in there trying to get their market share, bringing in new features. I reckon within 12 months, I reckon most of them will be self-leveling. These are the sort of features. It's like when we first started with printers. We all remember dot matrix printers. Most of us, some of us don't because we were a bit young. But we remember, how slow and cumbersome those things were and things like that. 3D printers is just the same. It's just early in its progress of technology, but eventually it's going to be right up there, and so we'll be able to just produce what we want. So the world of being able to be creative is getting closer and closer for everyone.
We have ticker tape machines before faxes.
What's that?
We had ticker tape
Yeah.
machines before
Yep.
faxes.
Yep, very true.
Yeah, no, but when you go on the internet and you actually see what they're doing with these 3D printers, in China they're building houses with 3D printers. So they have concrete extruding, and they just move this big machine onto the plot, and it just builds a house a day. So, and I said the new range of 3D printers, they're coming out with ones with PC boards, dual layer PC boards you can build yourself at home. For prototyping, that is just amazing because I said, in one day, you can sit there in front of your computer, pump out your design, and test it straight away. No waiting, nothing. You can say, okay, that's not right. Make your adjustments on your computer, bang, test it again. All right? Within one day, you've gone from conception to an actual product. Before, that would take months and months of back and forth to China, moulding costs, this, that, and the other. So, it's just opened up a whole new window of creativity. Phil, snap these up in no time. Great little device. No one would have been able to get these in the past because who would make these normally in the normal process of getting mould done? No one. But on a 3D printer, draw it up, make it, and you've got it. So I think it's something that a lot of us will start using in the future because as far as DIY hobby and our lighting, we're always trying to make up clips. We're always trying to make these things. We're always trying to make something, for ourselves to suit our own applications. And this was what will help us do it. So that's pretty much. Any questions?